Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve a question from Probability and Statistics 1. And this particular question belongs to paper 9709/41 for the session October November 24. Let's solve question number 7 and start reading the question. It says, how many different arrangements are there of the 9 letters in the word intellect in which the two T's are together? This is one of the easiest and simplest as well as most common question in probability and statistics paper 1, and we know the concept for solving number of arrangement is permutation, so we will apply the concept of permutation. Before that, let us see what is the restriction over here. The restriction is the two T's are together. So two T's are together. Let us draw the scenario. Total 9 letters: 1, 2, 3, 4, 5, 6, 7, 8, 9. Among them, they told that T's are together. Suppose these are the T's. Okay. And these T's will be considered to be 1 unit. So if these two T's are 1 unit, then total how many units are there? Surely there are 8 units. So we can write number of arrangements, number of arrangements equal to, so if we suppose both the T's are 1 unit, then there are total 8 different letters. So out for these 8 letters, 8 factorial ways they can be arranged. Okay, after that we will have to divide by the identical letters. We will not look at T because they are already in 1 unit. So rest of the identical letters, so what are there are two Is as well as 2 else identical. So we will divide by 2 factorial for 2 is and another 2 factorial for 2 else. So finally our result is going to be 8 factorial over, let me show using my calculator, 8 factorial over 8 factorial 8 factorial to be 10,080. 10,080. That is what the answer to the first question. Let's move on to the immediate next question. The next question says, how many different arrangements are there of the 9 letters in the word intellect in which there is a T at each end and the two T's are not next to each other? Well, so there are two restrictions. One after the other, we will get them solved. Let's see what is the first restriction. First restriction is there will be 80 at each end. So let's write 1, 9 spaces, 1, 2, 3, 4, 5, 6, 7, 8, 9. So at each end there will be a T. So T's have been arranged. So let us write number of arrangements when a T at a T is at a T at each end. Okay, so what will be the arrangement if there is a T at each end? So if we remove this or if we avoid this T's, then how many spaces are there, how many letters are left? 7 letters definitely. So it is going to be 7 factorial ways. 7 factorial ways. But there are two is as well as two else are identical. We know we will have to divide by 2 factorial by 2 factorial for 2 is and another 2 factorial for 2 r's, 2 else. So 7 factorial over 2 factorials over 2 into 2 factorials, that means 4. So we will divide by 7 factorial. Yes, 7 factorial. 7 arrangements for with this restriction is 1260, 1260. Well, there are two restrictions given in the question. We should not forget that. The second restriction is we should not get the two t's next to each other. So what does it mean? That means is cannot be together. We will reverse the concept. Let us find the number of arrangements when is are together, because I find it more comfortable and easier if we reverse the question. The reversal question will be what if is are together. They have used a not over here. They have used not. We are avoiding this not. We will see how many arrangements are there when t's are together. Well, so if t's are together, let us write the 9 step again. 9 letters: 1 2 3 4 5 6 7 8 9. T's are at the end and is are together. Is are together. So if these is are together, then look at this. This is now one unit. Okay, including these two is together, how many letters are there or how many places are there they can interchange among themselves? We can write number of arrangements, number of arrangements when a t at each end, at each end and at each end and is are together, and is are together, is are together. Okay, so if t's are at each end and is are together, let us see how many spaces are left. 1 2 3 4 5, and this one is as one unit, so total 6 factorial ways. Considering both the is as one unit, we get there are 6 places to interchange their locations among themselves. So it is going to be 6 factorial ways, and among them, among these 6 letters or 7 letters, there are 2 L's. Remember, 2 L's are identical, and we know we should divide by the number of identical letters. So 2 L's are identical, so we will divide by 2 factorial. So ultimately, what is the number of arrangements? We know 6 factorial means 720. If 720 is divided by 2, it is going to be 360. So 360 is the number of arrangements when the e's are together and there is 80 at each end. Now we are going back to the question so that we are not deviated from that. What does the question tell? The question tells t at each end and the two is are not next to each other, but we have supposed that the t's are next to each other. I mean, they told that t should not be together, but we have found the t should be together. That means if we subtract the number of arrangements when t's are together, sorry, is are together, then definitely we will get the number of arrangements. So let us write number of arrangements, number of arrangements, arrangements with both restrictions, with both restrictions, both restrictions with both restrictions, restrictions is equal to, so when t's are together, I mean only one condition or one restriction, the number of arrangements was 1260, and when the e's were together, I mean reversal of one of the restrictions, then number of arrangement was 360. So if we subtract this 360 from total number of arrangements, we will get our arrangements with both restrictions. 1260 minus 360. So finally number of arrangements is going to be 900. I think you got my points, because I have thought the second restriction in a reversal or different way, because when they tell a negative word not together, we always find what is the number of arrangement when they are together. After that, if we subtract that number of arrangements from whole of the arrangement, then we get our required arrangements with all restrictions. I think you have understood my point. Let's move on to the immediate next question. The next question is on the next page, and it says four letters have been selected. Four letters are selected at random from the 9 letters in the word intellect. Find the percentage of the possible selections which contains at least one E and exactly one T. So first of all, we should not forget that it's nothing but selection. Selection, or for selection and choice, our concept is combination instead of permutation. Permutation is applicable when selection as well as arrangement is the fact, then permutation is required. But in for only for selection, we can apply the combination formula well. So first of all, let's see what are the scenario. There are two is, okay, two is, then there are two t's. The restriction is about T and E. Look at this, E and T. So how many T's are there? Two T's. If four letters go away, out of 9 there remains 5. So we can write 5 others. 5 others letters. Okay. Then they have told at least one E. At least one E. Let's take one E. And exactly one T. So number of T cannot vary in different cases. So one E. If we choose two letters from these four, and totally there will be four letters. So from the remaining letters, we'll have to pick up two more. Okay. After that, let's see if we take they told that at least one E, we can take even two is. So two is, and we cannot avoid T because there must be an AT at each case. So from the remaining letters, how many letters can be taken? 2 plus 1, 3. So one more letter can be taken. And I think these are the all possible cases. Okay. So what is it going to be? Equal to, we have already decided that it is a concept of combination when we choose the letters or any objects from total number of objects. So from 2 is we are choosing 1. So 2, from 2 we are choosing 1, and again from 2 t's we are choosing 1. Then from 5 letters we are choosing 2 letters. Okay. So finally it is going to be choose one means actually two, you know, because if you choose one letter from two, so how many ways you can select? You will get two ways. So two, and from here also two, choose one. That means if you choose one letter from two, there will be two ways, or two times you can do this. And for five, if you choose two letters from five five letters, you will have to use 5 into 4 into 3 factorial ways over 2 into 3 factorial ways. That means 2 factorial ways and 3 factorial ways. So finally, what is it going to be? We will have to erase this part. Finally, we are getting, it is 2 twos are 4 into 5 for 3 factorials and 3 factorials, they can dissolve each other. If 3 factorials can dissolve each other, there remains 20, so it is going to be 10. So finally, there are 40 ways of selecting these letters. So the first possible case, and the second possible case was what? We have written that there are, we can take maximum 2 is and 1 t, because about t there is only one restriction, and that must be exactly everywhere 1 t. So if we take three letters from e and t, so one more letter should be chosen from the five remaining letters. So what is the result? It is going to be 2 choose 2. From 2 we are choosing 2, and from 2 t's we are choosing 1, and from 5 letters we are choosing again 1. So what is it going to be? From 2 letters, if we choose 2, there is only one way, because both the letters are being chosen. And from 2 letters, if we choose one by one, there are two ways. From 5 letters, if we choose one, there will be 5 ways, because 1 1 1 1, total 5 ways you can select. So total number of selection is what? Equal to, total number of selection with this restriction is 10. So total how many? Now if you look at this, first we got 40, then we got 10. So we can write number of selection with restrictions. So what is the total number of selections with restriction is 40 plus 10 means 50. So with restriction, number of selection is 50. We should not deviate. We should not get deviated from the question. Look at this. They have told to find the percentage, not to find the number of selection. They have told us to find the percentage. So for percentage, we should know that what is the total number of selection without any restriction. So number of total selection, number of selections total selections total number of selections, the same concept we are going to apply, is equal to total. There are 9 letters. Out of 9 we are going to choose 4. Okay, so it is going to be 9 factorial over 4 factorial into 5 factorial. Okay, now let us see what is the total number of selection if we choose 4 letters from 9 letters. Let us use our calculator. So 9 letters, 9 over, yes, over here, 9 factorial over restriction is 126. 126. Well, Now we are going to find the percentage. Hence percentage is equal to, so total it was with restriction, it was 50. So 50 over 126, 50 over 126 into 100%. Okay, into 100%. So let us divide 50 divided by 126 is 50 divided by 126 divided by 7 equal to, 39.7%. Okay, and this one can be written just beside this 126. So that's all about the solution to question number 7, which is the last of all questions of this paper, and it is not twisted or difficult at all. I think you have understood it very easily, because this is one of the most common and simplest of all questions as well as solutions. So thank you all for being with me. May Allah bless us all with the beneficial and humane knowledge. Fi amanillah. Let me write here answer. This is the final step, so there will be answer. Allah Hafiz.